Hello, my name is Frode Eskelund and I am working as a developer at Radiocrafts. Today I will talk a little bit about how to achieve the lowest possible power consumption using RIIM. So in this demonstration I have connected two boards via RF, one border router and one mesh router. You have to keep in mind that all current consumption through, say, GPIOs, UART, and so forth will influence the measurements, of course. So what I have done here is to connect the power supply from so-called Power Profiler Kit 2 from Nordic Semiconductors. And disconnected the UART to the module to avoid any stray power consumption from GPIOs and so forth. Looking at the project, I have now just made another sub-project into the RIIM SDK and open it in Visual Studio Code. So as you can see here under sources, I have two sources here, one for the border router, which I show you here. This basically just includes a very basic setup of a border router. There is nothing special here. We set up a key, we set up the channels and all those standard things. For the mesh router, it's a little bit more complicated. What we have here is first we set up a constant, which is a wake-up timer period. So what we try to achieve now is for the module to start asleep and then wake up after 60 seconds. This is the wake-up function. It's basically just starts the mesh router, or if you prefer to use single channel, it will start a leaf. One thing that is important here is to set up your GPIOs correctly. So what you need to do is to have them as, well, they could be output instead of input, but you need to have them at a certain specific level. So in this case, we have put them to pull down. This is the timer that we will use. This will just wake up the module after 60 seconds, as I mentioned. And this is just a standard setup with the keys and everything. And this just says, okay, the first thing that you do is just to go to deep sleep. And after 60 seconds, this is the function that will be called and wake up the mesh router. So let's have a look at the actual power consumption here. I have connected the power profiler kit to the board. I enable the power, start the measurement, and I hold the reset button down. So I release it now, and you see that for a brief period it wakes up, uses quite a bit of power, and then it goes to sleep. And what we can see here is that the sleep current now is between 2.5 and 2.8 maybe microamps. And this is what we expect when the module is sleeping. So this was when we started the module, and this is when it is asleep. So you see that there is quite a big difference. The module in sleep won't do much. It is deaf, so it can't hear anything on radio. You can't send anything either. So this is more of a mode that you can use in situations where you are to be powered down for an extended period of time. Now, after a minute, it should wake up. So let's have a look. And there it wakes up. And now it connects to the network again and is alive. And now the current consumption is to around 180 to 200 microamps. And that is what we expect when it is actually active. It is now connected to the network as well. So if we zoom in here a little bit, you see that it uses quite a bit of power to join the network. And afterwards, it is of course much lower. So this is basically what you should expect to see when you enter our lowest power mode using the RIIM module. This mode is suitable for when the module is supposed to be powered down for extended periods of time, such as, say, when it's on the shelf or it's not able to reach a network or something like that, to avoid it to use all the battery.